Alright, since the week 2 video had no audio, I'm going to record a new one, but this one will be a bit faster than the previous one since we practiced everything and we did everything inside the lab, so it's just a review of what we did. I'm going to open my VS Code and then I'm going to click on the open folder and I will go to the folder which is containing my lab folder, which is my desktop directory. So let's go there, and this is the comp 2152 labs, which already has the readme and week 1. So let's open this folder. You'll see the folder structure is showing at the left side of the VS Code. So what I'm going to do first is to creating the week 02 folder. This will be automatically going after week 1, so this is what we are looking for, and I'm going to create a new file inside of it called lab02.py. so lab2 Python. What we are going to build in lab2 is a rock paper scissors game. So let me close this side and start my code here. One of the things we are going to practice with this lab is creating a list. We know that the indicator of a list is square bracket. So, and what we'll have as an option for rock paper scissors game, we know them, it's rock, paper, and scissors. Scissors, perfect. So now we have our list, but we need to save it somewhere in a variable. So I will call this choices. So to implement the game of rock, paper, scissors, we will have these 3 choices. To debug my code, if I create my choices list correctly, I can just simply print these choices here. So let's open the terminal. We all know how to open the terminal by now, but if you don't know, you have to press the Control key beside the back tick on your keyboard. So to start, first I need to make an alias. So let's make this alias on your Mac, and if you have Windows, you can also do this in your Git bash. There's no harm, but this is mostly for the Mac users. So then I will say, let's first check what is our current working directory. This is lab folder, so means that inside of it I will have week 1 and week 2, and inside the week 2 I have my lab02. So to run the application I need to say Python week 2 and then the lab file. Okay, let's go. As you can see, I have my options correctly here and everything seems fine. I don't need this print, that was just for debugging. Next, I need to receive inputs from the users. So the built-in function of input will be enough to receive the choices of the user who is playing the game. But we know that the input itself is not showing any message. So if I run my application, you'll see it's waiting for the input. For example, hi, this is my input, and if I press enter, the application will be stop interpreting. So what I need is to have an appropriate message for this input. So I can say enter your choice, and I can tell the user what they need to provide as their choices. So 1 for the rock, 2 for the paper, and number 3 for scissors. So scissors, very good. And then, like always, we need to save it somewhere. So I will create a variable called player choice, which will be equal to this. And then for debugging and troubleshooting, I can just do a print here to see if that user input was correctly saved in the variable. So let's run the application and let's say, for example, number 1. That's good, but it would be more appropriate if I put a column here and one space after column. So let's run it again. That's perfectly fine. Again, that print statement was only for the debugging. I don't need that for now. Okay. Now what I need to do is I need to do a type conversion for this player choice. I could put the let's do the simple one first. So player choice will be equal to integer version for type conversion of the player choice. This is the simplest way to doing that, but always you can put the int to, because we are receiving a number, and input function will always return a string. So I can do the casting here, but to keep it simpler and more readable for junior Python developers, I will keep it like this. So what else I need to do? I need to build my game logic. So I will start here. I will say if the player choice was less than number 1, or the player choice was higher than number 3, we need to throw an error. So we can say in the console, error choice should be between 1 and number 3. Number 1 and number 3. Just an exclamation mark here. Very good. And the rest of the logic will be here. Now I need to create another player which our player will be playing against them. For us here is the computer. We are playing against the computer. So computer choice will be equal to, so I can do it statically. I can receive it from an input from end user, but there is another way to make it more realistic, to have more realistic game. And how can I do that? I can get the choice from the computer from this built-in random package built into the Python. So as you can see, when I write random here, there is this yellow line and the color is white. If I go to line 1 and create a new line and write import random, again this random is a built-in package to Python, you will see first of all the yellow underline will be disappear and the color will be also changed to green. What I need from random package is random integer, and we need to have a choice between number 1 and number 3. So 1, 2, and 3 will be accepted for the computer. So now we have the choice for the end user, we have the choice for computer. We can start building the winner, tie, or loser logic. First thing I'm going to say here is I'm going to say if the player choice was totally equal to computer choice, you can say this is a tie. So print it's a tie. On the other hand, I can have my second condition using else if or elif keyword, and it will be player choice. If the player was using rock as their choice and computer was using, for example, option 3, which is scissors, so player will win. So I can say print rock beats scissors, you win. So first condition for the player to win the game. Second condition is when player choose paper and computer choose rock. So we know that paper beats rock, and again player wins. For the last condition, the player could win the game is this one, which player choose the scissors and computer choose the paper. So scissors beats the paper and they won the game. In any other condition, so else, player will lose the game. So let's say you lose and an exclamation mark here. Very good. This is the simplest way for the week 2 of Python course. So I know there are a lot of optimization we can apply, but we want to keep it simple. So now let's run the game to see how does it work. First, I'm going to provide out of bound numbers, for example 0. See, there is an error, and for example number 4, there is an error showing us what is the correct option. Now let's go with rock. So we choose rock, computer choose rock, it's a tie. One more time. Oh, I choose the paper and computer choose the scissors. They won. One more time, I'm going to choose paper, and this time computer choose rock, and I won. It's working perfectly fine. So what I need to do is I need to add whatever I did to the local Git repository. So git add dot. Then I need to commit them. So to the, again, local repository, git commit. Let me change the size of the VS Code. Git commit -m add week02 solution. Okay, and then git push to have all of it in my remote Git repository. What you need to provide me as submission is this screenshot. So let me take this screenshot and show you what do I need. So we need a screenshot like this, and the Git repository of the user. The user currently I'm working with is this one. So let me put it here so you can see. This is the random user I have created for this course, and this is the URL we need. So let me open my text editor to show you what you need to provide. So just this link, which is to your repository, instead of this string here, com2152 winter 26, you need to provide your own username. Do not provide these X's, just your own username, and it should be the same repository name and a screenshot of git add, git commit, and git push. If I go to my Git repository like this, you'll see just a few minutes ago, 1 minute ago, Vic2 has been added, and there is lab02.py, and it has the exact same code we wrote together. That was it for Vic2. I hope you could catch up with all the requirements of the Vic2. See you in the lab.